Hey guys, this looks like a fun one. We have 9 to the power of x minus 5 over 4 to the power of x minus 8 equals 144. In order to solve this, I think we need these notes for exponents and these notes for logarithms. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, let's split these up like this. I don't really like fractions. Let's see if we can get rid of this fraction. This 1 over 4 to the x minus 8 reminds me of this piece of notes right here. 1 over a to the b is equal to a to the negative b. So that means that 1 over 4 to the x minus 8 is equal to 4 to the negative x minus 8. And now the fraction is gone. One more step, this negative can be distributed to both of these, which will give us negative x plus 8. And we can rearrange this to 8 minus x. So I think 4 to the 8 minus x is way better than this whole thing. Let's replace it. Next, I don't really like that this 9 and this 4 don't match. Let's focus on this 9 and let's see if we can give it a common base. And these notes will enable us to do that. It says a is equal to b to the power of log base b of a. Well, let's apply this to our problem. I want to change this a into 9 to the x minus 5, and we'll also change this a into 9 to the x minus 5. And b can be anything we want. Let's make it match this 4. So we'll change the b's into 4s. So now we know this thing is equal to 4 log 4 of this thing. So we can just shift this up here and put in the 4 log 4. And now these have a common base of 4. So this exponent up here is a little crazy, so let's focus on that. When you're dealing with logarithms, we can take this c exponent and bring it to the front. We're going to bring that exponent to the front. I think this looks much better. Now let's take advantage of the fact we made these two bases match. We can use these notes right here. Anytime you multiply two powers to the same base, you can just add the exponents. So since both of these are equal to 4, we can just add these two exponents. Well, that's nice. Now things really look clean. Since our variable x is stuck in the exponent and the base is a 4, we're going to do log base 4 to both sides. This is the reason we created logarithms, was to get variables out of the exponent. And these are the notes that show that. Anytime the base of the log equals the base of the power, the exponent can just be brought out. So this can go away and our exponent can be brought down. And that's how the logarithm got the variable out of the exponent. Next, let's leave this alone for a minute and let's focus on this right-hand side. Log base 4 of 144. Well, 144 is equal to 9 times 16. And we can break the 16 down into 4 squared. Now let's look at these notes right here. Anytime you have a logarithm where the argument is a product of things, you can rewrite it as a sum of logs. So we can split this into two separate logs where the first one has an argument of 9 and the second has an argument of 4 squared. And then we can clean this up. Since the base of the log is equal to the base of this exponent, we can bring the exponent down and this stuff will go away. So we have now found that log base 4 of 144 is equal to log base 4 of 9 plus 2. So we can update this right here. Now let's go back to the left-hand side. This log base 4 of 9 can distribute to both of these terms. So we'll have x log base 4 of 9 minus 5 log base 4 of 9. And then we're going to add to that 8 minus x. And that's all still equal to this. Now let's try to get these two x's by themselves. Let's add 5 log base 4 of 9 to both sides, and let's subtract 8 from both sides. This stuff will all go away. So on the left-hand side, we'll have x log base 4 of 9 minus x. And on the right-hand side, log base 4 of 9 plus 5 log base 4 of 9 is equal to 6 log base 4 of 9. And then positive 2 minus 8 is negative 6. Next, on the left-hand side, both of these terms have an x, so we can factor out the x. X times what gives us this first term? That's log base 4 of 9. And then x times what gives us negative x? Well, that's negative 1. And then on the other side, both terms have a 6, so we can factor out a 6. 6 times what gives us this? Well, that's log base 4 of 9. And then 6 times what gives us negative 6? Well, that's negative 1. So now we factored both sides of the equation. Both sides have a log base 4 of 9 minus 1, so let's divide both sides by log base 4 of 9 minus 1. These are gone, and that leaves us with x equals 6. So after all that work, we got x equals 6 as a possible solution. Let's plug it in and see if it works. Here's our original expression. In the place of the x, let's plug in 6. In the place of this x, let's plug in 6. 6 minus 5 is equal to 1, and 6 minus 8 is equal to negative 2. 9 to the 1 is the same thing as 9. This 4 to the negative 2 on bottom, we can bring it up and become a 4 to the positive 2. On bottom, the exponent's negative, and on top, the exponent's positive. And if you want to see another way to think of this, we can multiply top and bottom of this fraction by 4 squared. On bottom, 4 to the negative 2 times 4 to the 2 ends up being 4 to the 0, and 4 to the 0 is equal to 1. So this will become 9 times 4 squared. 4 squared is equal to 16, and 9 times 16 is 144. So it checks out. X equals 6 is the answer to our question. Let's put a box around it. How exciting.